All right, folks, it's Fast Action, back in action. On this page of notes, we are going to look at the fact that the area of a triangle can be found three different ways in any given triangle. And this is often a complicated topic for students, so I want to work through two thorough examples here, so when you encounter these later, you always have a video that you can come back to and look at why this makes sense and how you can tackle these types of problems. So up here at the top first, we're going to look at the fact that an altitude is also called the height in a triangle. Okay, so let's review that idea. So altitude and height are the same thing, and that there are three altitudes in every single triangle. And then, of course, we know the area of a triangle. We can rewrite that here. Area is 1/2 base times height. So we typically write it as base times height, but we can think of it as 1/2 base times altitude. So let's take a look at this first problem that I've got right here. I've got this triangle and I've drawn in all three altitudes. Now these are given as altitudes, and of course this only works if they're altitudes. It's not going to work if they're angle bisectors or anything like that. So what we first want to look at is how we could write the area of this triangle three different ways. So the first thing that I'm going to take a look at is if this is my altitude, then this would be my base. So if I wanted to write the area of this triangle, I would say area is 1/2, and I would write BG, my segment BG, times my segment AC. Okay. Then I can look at a different altitude. Let's say I'm going to look at altitude AJ here. Let's say I look at this altitude right here. Well, that altitude then is going to be perpendicular to this base. So if we want to write that, then we would say the area of our triangle is going to be 1/2 AJ times its base of BC. And then my last one, I'm going to look at this altitude right here, and I'm going to look at its base. And I can write that one as well. So the area there would be 1/2. Its base is CW, or its altitude is CW, and its base is BA. Okay, so now that we have each of those, we can take a look at the various given information that we have, and we can just start substituting in what do we know. So I've got AC is 25, and I'm just going to read through each of these and put them in their appropriate places. So my AC is 25, so I'm going to find my formula where I've got the 25, and I'm going to fill that in. The next thing I'm given is BC is 32, so I'm going to fill that in here as 32. And AB is 20, so I'm going to fill that in here as 20. And then the last thing that I'm given is that the area of the triangle is 384. So we're going to go ahead and we're going to fill that in, 384. At that point, we can actually finish writing these formulas, and I'm just going to rewrite the BG as BG. If you feel more comfortable, you can write that as a variable of X. But you'd want to use a different variable throughout this whole problem. So again, the area is 384, and I would still have the 1/2, but this time I don't know AJ on the next formula. And on the next one, I've got 384, and I have my 1/2, and this time I don't know the CW. So what we can see here is that setting each of these up as the product of its base, 1/2 the product of its base times its height would get the area, but the area for the triangle is going to remain consistent throughout each of the problems. So if you just simply do that quick little algebra there, what you'll get, you can pause this and just try them in your own calculator, make sure you can get these. You would get BG is going to be 30.72. We're going to go ahead and write these as decimals. Okay, then the next one we'll get our AJ is 24. Of course, if you wanted to leave these as the fractions or reduced fraction, I would certainly accept that. And on this one, we've got CW is going to be 38.4. Okay, so make sure that you are comfortable with that algebra. I'm certainly not making that the focus of this video. The focus here is just the fact that we can calculate our area three different ways. So let's take a look at another one. We're going to swap out how our information is given and how it's useful for us. So let's take a look at another one here. This time I have an obtuse triangle. Again, I've drawn in the altitudes. Those are going to be the dashed lines. So we can start off with finding an altitude. So let's say I'm looking at this altitude of AW. So the base that altitude is perpendicular to is only this segment BC. Notice that I'm excluding this little part here that's WB. So when I write that formula, I'm going to say area is going to be 1/2, and I can say AW, and I can say BC. Now remember, it doesn't matter if you reverse that multiplication because multiplication is commutative, so we can do it in whatever order we want. Then I'm going to move on to the next one. This time I'm going to look at this altitude first. So this altitude of CG, and it's going to be perpendicular to this segment right here. Now, if you're kind of confused on some of these pictures, this is what we did back in Chapter 5. So you can always go back and look at your Chapter 5 notes when we were actually constructing these various altitudes. That might help you understand a little bit more why these altitudes are outside the triangle. So on this next one, I'm going to say the area is going to be 1/2, and I'm going to say CG times my AB. And then I'm going to find my third altitude. That one's going to be inside my triangle, and it's going to be perpendicular to this last side. And I can write that one out and say the area is 1/2. And this time I can say JB and AC. Okay. So just like we did before, we're going to go back through and we're going to substitute in our given information for whatever parts that we know. So we're going to fill that in. So AC is 15, so I'm going to find my equation that has the 15 in it. AB is 6, so I'm going to find that as a 6. And AW is 5, so I'm going to fill in the 5 there. And CG is 9. So what I notice here when I fill this in is that I actually am able to calculate the area of the triangle using the blue segments. So I'm going to go ahead and I'm going to finish that off. So I'm going to have 1/2 9 times 6, or in other words, it might be a little easier to think 1/2 times 6 is 3. So really I just have 3 times 9. So I've got my 27 there. So the area of my triangle is actually 27 units squared, because I didn't give you a unit of measure. Now that's going to be useful for us because that area number then can be used to plug in right here. And then we're back to a problem that looks like what we did in the previous problem. So we can solve this one and solve for BC. And if you did that algebra, you would get BC is 10.8. Make sure you're actually doing this algebra and you're not just jotting down these numbers. And then we can also use that area number right here, and I can fill it in on my other equation, and I can say 1/2 JB times the 15. And again, just do that quick little algebra there, and we get the measure of JB is 3.6. Okay, so we're going to do a whole bunch more practice with this, but make sure that this is kind of making sense to you and how I'm pulling out and matching up those bases and heights.